Hey y'all, today we're going to be learning about section 6.5, which is on fossil fuels. Learning objective for today is that you can describe the use and methods of fossil fuels in power generation, and that you can describe the effects of fossil fuels on the environment. Some of the essential knowledge that you're going to gain is how the combustion of fossil fuels works, how we get energy from fossil fuels, the different methods that humans use to extract these fossil fuels, and we will also learn a bit about the process of fracking. So we're first going to talk about fossil fuel combustion. And this is where we get our energy from fossil fuels, is because of this reaction. So you have oxygen molecules and then fossil fuels, which are just hydrocarbons. They are molecules that have carbon with some hydrogen attached to them. So we have that oxygen react with those fossil fuels. And this reaction is going to release energy in the form of heat. It also is going to produce carbon dioxide and water as byproducts, but this releasing energy of heat is ultimately how we are able to eventually get electricity from this combustion reaction. So one thing that's important to remember is that combustion is a step in the carbon cycle. Because the fossil fuels are hydrocarbons, when we are burning them, it's releasing energy in the form of heat, and it's also going to be releasing the carbon that is stored in these hydrocarbons, which then opens it up to react with oxygen in the air, which will ultimately form carbon dioxide. So this whole process is very much connected to the carbon cycle because carbons are the atoms that are going to be involved in this, some of the atoms. So if we look at this combustion reaction, basically you have oxygen here and then you have this hydrocarbon fuel. We are going to need to use heat in order to break apart these bonds. So it does take a bit of energy into it to get this thing going, but you're going to break apart the bonds in the oxygen and the hydrocarbon. Once they are broken up, then we are going to have some new molecules forming that are going to be carbon dioxide and water. Now, this fossil fuel combustion is going to be the same process or the same release of energy for all of our fossil fuels. So we've got methane, natural gas, gasoline, propane, butane, coal. All of them are hydrocarbons. So all of them, it's going to be the same general combustion reaction occurring. Additionally, wood and biomass also work the same way because carbon's going to be burned and it's going to react with oxygen to form carbon dioxide and give off energy. So this is kind of the general reaction to be aware of for how this works. And if we look at kind of a simplified chemical reaction for it, we start with oxygen and we start with the hydrocarbon. When energy is going to, you'll need a little bit inputted, but you will also get a release of energy. And afterwards, you're going to have carbon dioxide and water as the products in this reaction. So now how is it that we take these fossil fuels and generate electricity? Well, the number one source of electricity production globally is coal. So it's important to remember that when we're talking about these. Although all of them are going to work generally the same, coal is the main one that we tend to be talking about globally. However, natural gas is going to be the next most common one. So the general steps for electricity generation are going to be the same, no matter what you're burning, no matter what type of fossil fuel, in order to get this heat. So we are going to use heat, which is going to turn water into steam. Steam is going to then turn a turbine, which is like a big fan. This turbine is going to power a generator. The generator is going to produce electricity. So at the very beginning of this, the heat came from the heat that is released from this combustion reaction. So heat is released. This heat is then used to make the steam, which turns the turbine, which powers the generator, which produces electricity. So it's this step by step. And ultimately, it started with the combustion of these fossil fuels with the heat. So if you look at this diagram here, We've got some water is going to be coming in. In here, in this boiler, is where we are going to be having that combustion occurring that's going to be releasing heat. Now, we've got this water in this tiny little pipe, which steam, when it's going through that, is going to be pushing through really fast. So it's going to shoot through this pipe. It's going to hit the turbine, which will spin the turbine, which then goes to a generator, and the generator is going to produce electricity. Now, for this class, we don't need to know all the details of how this generator works, but essentially it's kind of involved in like some magnets and electricity is produced from it. And that's basically the level that you need to know for this class. So as I said, we can use coal, oil, natural gas, biomass, honestly, even trash. All these can be burned to drive the same process to create energy. Even nuclear energy, which we will talk about in future notes, works similarly. It's just nuclear fission producing the initial heat instead of the combustion of fossil fuels. But all of these things are going to be going in to cause the release of heat that is going to be what starts this process going. So now let's look at some environmental consequences of this very common method for producing electricity, specifically looking at coal. So when we are going to be mining this coal, the first consequence that comes up is that habitat destruction is going to occur as we are clearing the land for mining. Additionally, coal is going to produce pollutants and release carbon dioxide, which is a greenhouse gas, which leads to global warming. Now, it's important to keep in mind pollutants and carbon dioxide are different things. Carbon dioxide is a greenhouse gas. It's not a pollutant. It's a naturally occurring molecule in our atmosphere, and the problem comes from it being a global greenhouse gas, which leads to global warming. Pollutants are going to be harmful molecules that are released from this. So keep in mind when we're talking about the carbon dioxide, burning coal is going to release more carbon dioxide than any of our other fossil fuels when it's burned for electricity generation. So this is why using coal for electricity is causing more greenhouse gases and global warming because it releases more carbon dioxide than any of the other fossil fuels. So if we're looking at the amount of carbon dioxide that is released from all different processes, power plants using the combustion of coal are going to be the big one. Now, the pollutants that are going to be released, we've got a few of them. The first one is going to be particulate matter, such as soot and ash, which can irritate the respiratory tract of humans and animals. This process of doing the fossil fuel combustion produces toxic ash, which is contaminated with lead and mercury and arsenic. Now, generally, this ash is going to be taken to landfills or stored in ash ponds. However, landfills and these ponds can leak into grounds, surface water, or into the soil. And lead, mercury, and arsenic are all poisonous. So if you look at this diagram here, this would be like a coal ash pond and all of the different places where it could potentially get and infiltrate. Now, another pollutant that is released from this, which we will learn some more about these molecules in our air pollution unit, but we're going to have different SOx and NOx, which stands for sulfur oxide and nitrogen oxides. The little X represents that we have different molecules here, but for short, you can call them SOx and NOx. And these are going to irritate respiratory systems as well as contribute to smog and acid rain. So all of these are going to be some different pollutants in addition to the carbon dioxide and habitat destruction. All of these are reasons why using coal for energy is not good for the environment. So now let's talk about generating electricity. Coal is about 30% efficient as a fuel source. So that means that 30% of the energy from the bonds in the hydrocarbons are actually converted to electricity that we can use. Natural gas is much more efficient. It's actually about 60% efficiency when it's burned to generate electricity. But you might notice these are still not like 100%. These are lower numbers. And this is because if you remember back when we talked about like our trophic cascades and everything, a lot of energy is lost in the form of heat in all these processes. And so this heat that is released is not able to be converted into electricity. So it's just going to escape out into the atmosphere as heat. Now, there are ways that theoretically we could actually make things a little bit more efficient if we were to use this heat for something. So there's this thing called cogeneration, and this is when you use the heat produced from electricity generation and you use it to provide heat, either heating water or air, to a building. So if you have these combined heat and power systems, these are actually close to 90% efficiency, which is going to be much better than just using coal or natural gas just by themselves. So if you look at this diagram here, in a typical system, you will use fuel for power plants, and then you will also use fuel for heating buildings through boilers, or you can use like hot water heater, stuff like that. But essentially, we'll just pretend boiler is the one that we're using here. And both of these processes, you're going to be losing energy in the form of heat. So with a power plant, you're losing about 35% of it, and then 21% of it is going to go into useful energy. With your boiler, you're going to lose some of it as heat. You're going to have some more of it as usable heat that is actually warming the buildings. And so that's going to be kind of our effectiveness here. Now, if instead you were to use a combined heat and power system, this fuel that goes into power, you can also harness the heat that's being released and use it to warm buildings, which makes it a much more efficient system. So this is a way where we could make combustion of fossil fuels more efficient for multiple purposes. Now, you have seen these notes before, so you do not need to write them down, but since we're talking about oil and petroleum and fossil fuels, I'm just going to really quickly recap it and a reminder of how it is that we extract this oil and petroleum from the environment. So you're going to have these wells that dig down and harvest it directly from oil reserves, but also we can get it from tar sands, which cause more energy and water, but it's a way that you can get petroleum from that bitumen, which is the kind of more tar level of it. So just a reminder that there's a few different methods of extracting this petroleum. And again, you don't need to rewrite this again. You already have it in your notes from 6.3. So now let's talk about some environmental consequences of those tar sands and using that extraction method. So the first is going to be habitat destruction, because you need to clear the land for roads, for the drilling equipment, for digging through the ground surface to actually reach the deposits. And you're just going to be destroying kind of that biodiversity and the habitat. So if you look at this image here, this was previously a forest, and right up next to it is where we are going to be having this tar sand mining. You can see that clearly we destroyed the habitat, but it's also leading to habitat fragmentation, which is also not going to be beneficial for general biodiversity of these forests. Additionally, some consequences is that you're going to have ground or nearby surface water depletion, because you need to use this water for steam and for washing impurities from the bitumen at the refinery. And the way that we can get this water contamination from this water that was used, not only do we deplete it, but we also contaminate it. You're going to have these tailing ponds, which are holes that are dug for storing the wastewater of these processes. These tailing ponds can overflow and run into nearby surface waters or leach into groundwater, and these are going to be contaminated with benzene, which is a carcinogen. They also have salts, acids, hydrocarbons, and little bits of bitumen left in it. And so all of this is like kind of yucky water that can get into other places. All of these things that it's contaminated with are very much toxic to plant and animals, and therefore humans. So it's definitely not good when these run into local groundwater or surface waters. So this is going to be an example of what these tailing ponds can look like. And clearly it's going to be pretty easy for that to flood and get into other local waterways. Additionally, you are going to have carbon dioxide released by all of this machinery that is used for extraction, transport, and refinement. So now we're going to look at the environmental consequences of the crude oil and petroleum, which is not the tar sands, but it's more where you're like digging directly into it. So the first big consequence is that when you have this oil, you have a possibility of oil spills, which can happen in a few different places. It can actually happen directly from the pipes breaking. It can also be from tanker ships that are carrying the oil. Those can spill into the ocean. Now, if you have it spill into water, that oil just covers the top layer. It's going to block the sun for all of the organisms that do photosynthesis. It's going to clog fish gills. It's going to suffocate many ocean animals. It's going to stick to bird feathers, which makes it so that they can't regulate their temperature. And so they're going to freeze to death. And then as they're pruning themselves of this oily feather gunk, they're going to be ingesting that as well. So birds and oil spills generally don't do very well. As you can see, an example of this water bird right here in an oil spill. Now, if this spill occurs on land, it's going to be toxic to plant roots. It can get into the surface or groundwater and contaminate those. And then you're going to end up with hydrocarbons and crude oil in your local waterways, which, if it's surface water, once again, you've got all the problems of the spills that occur in water and what those do. Another problem that comes from the petroleum is going to be, or the petroleum extraction, is going to be, once again, habitat loss and habitat fragmentation when land is cleared for roads, drilling equipment, and pipelines. And you can see this is an example of an oil pipeline, which that pipeline can spill, happens all the time. And it also, you can see the entire road that has divided this forest in order to get this pipeline through. Now we're going to talk about fracking, which is also, fracking is the short version. The actual name for this process is hydraulic fracturing. And this process is how we get natural gas from sedimentary rock. So you've got this vertical well that's drilled down into the sedimentary rock layer. It then is going to turn horizontally into the rock layer, which you can see here by this, like, looks like a pipe of water. And down here at this area where it's going to be horizontal, you're going to have little cracks that are going to form around that horizontal well, which is going to make it more permeable so you can get things out of it. You're then going to push fracking fluid, which has water, salts, and detergents and acids. It's pumped into the well at really high pressures, which continues to crack this rock even more. And then it releases the natural gas and allows it to flow out. The natural gas is then collected up at the surface, and it is shipped to places where it can be processed so that it's in a usable form. You also have, from this process, something that's called flowback water, which is the water that was used in the fracking fluids. This is going to flow back out of the well and then is collected and stored in containers or ponds nearby because it has a bunch of stuff mixed into it and it is contaminated. And so you can't just go and use it again. You've just got to store this contaminated water. So if you look at this little image here, it's going to show you kind of all the different things that are in the fracturing fluid. 90% of it is water, but then we also have some sand, some sodium chloride, ethylene glycol, borate salt, sodium potassium carbonate, guar gum, and isopropanol, which is all used for different parts. But that's what I mean when I say it's not just normal water, it's contaminated with all of this stuff. Now for the environmental consequences of fracking. Now, one of the problems is that the well can leak, and that contaminated water that was in the well is now going to be contaminating the local groundwater with that fracking fluid or with the hydrocarbons. Additionally, the ponds that you make of that fracking fluid, those can overflow and leach into the ground and contaminate surface or groundwater with this fracking fluid. So if you look here, this is going to be an image of like what these ponds look like. So that can contaminate local water sources. These salts and detergents and hydrocarbons can be toxic to plants and animals that rely on the now contaminated water sources after things have overflown. Additionally, in order to do this process, you are going to be depleting local ground or surface water nearby because you have to draw this water out to mix it in with the other stuff to make this fracking fluid. Now, an interesting thing that scientists are starting to collect data on and realize is that fracking is starting to be connected with increased earthquakes because of this wastewater injecting wells and then this fracking fluid, which is being stored deep underground. So, as of this point, scientists haven't proven anything, but we're seeing some correlation. And so scientists have a hypothesis that some of these increased earthquakes are due to fracking. So if you look at this data that was collected in Oklahoma, which is a place where a lot of fracking happens, if you look at around 2008, which is when we started to have our big boom of fracking here in the United States, these were the amount of magnitude 3.0 and greater earthquakes before then. We were having like on average 1.6 a year. After 2008, this is how many of these earthquakes we were starting to have. I mean, in 2015, we had as many as 887, which is clearly way more than the 1.6 on average that Oklahoma was having. So again, not totally proven yet, but some scientists definitely feel like they're going to be able to prove it at some point. So that is going to be another environmental consequence of fracking. In addition to habitat loss and greenhouse gas release. So here's going to be your practice FRQ for 6.5. I want you to explain one environmental consequence of tar sand petroleum extraction, and then I want you to explain one different environmental consequence of fracking. So those were your notes on 6.5, and that is your practice FRQ for 6.5, all about fossil fuels.